Let's get started with the webinar. A very good morning to all of you. I am Ramandeep Sandhu, Product Architect for the Orion product family at Interra Systems. Welcome to this webinar session on holistic OTT monitoring with Orion Central Manager that I will be hosting along with my colleagues Ashish Basu, EVP Global Sales and Business Development, and Ashish Saspera, Product Specialist and Application Engineer, as my co-panelists. So in this session today, we will touch upon various aspects of OTT monitoring and look at how Interra's Orion Suite and specifically the Orion Central Manager enables centralized enterprise-wide monitoring for network and broadcast operations. To get started, let me briefly introduce our company, Interra Systems. Founded back in 2000, Interra Systems has been a global provider of enterprise-class solutions for content QC, monitoring, and analysis. With headquarters in Cupertino, California, we have multiple offices in US, UK, Europe, and the APAC. Our products are built around the end-to-end media workflow and help you with the service assurance from content preparation to distribution. For instance, our Vega media analyzers are used for compliance and debug by encoder and video equipment manufacturers. The Baden Suite is an industry-leading enterprise-class automated file-based QC solution that offers comprehensive QC capabilities for checking content readiness during the preparation stage. Baten Captions and Lip Sync are recent additions to the suite and offer solutions for some very tricky and intricate problems of syncing audio with the captions and some old legacy problems of lip sync. On the other hand, Vino is an AI and ML-based advanced platform for content classification. The one that is particularly of interest to us today in this session is the Orion Suite that offers end-to-end monitoring for linear and OTT delivery, assuring quality of experience and quality of service right from ingest of live streams to the point where the content is consumed on the end devices. In the OTT space, we have a very well-knitted integration and some very good technology partnerships with other solutions that coexist in the ecosystem. For example, on the DRM side, we have integrations with Ardato, Verimetrics, ByDRM, and also support for some of the native DRMs like Fairplay, PlayReady, and Widevine. On the analytics side, we have a very close integration with NPOS Jobora that is used for end device monitoring and analytics. Our solutions are software only and fully supported on the various cloud platforms. We also have technology partnerships with all the popular transcoders and packagers that are used in the OTT world. And with a rich REST API support, our tools integrate pretty well with quite a few OVP and NMS solutions like Skyline, Kaltura, Broadpeak, etc. Well, next, let's have a look at the OTT workflow. I'm sure most of you can easily relate to this. So with live and VOD content coming in from various sources, it is transcoded to various bit rates. The content for IPTV and DTH is multiplexed and fed to the distribution network, whereas content for OTT is further packaged into different ABR formats, published onto the origin servers, from where it is served to the end client devices via one or more CDNs and the last mile internet network. The OTT workflow, as we see, is fairly complex. The content is modified at multiple points, and the distribution too happens over an unmanaged public internet network. So issues are bound to creep in and propagate downstream from anywhere in the workflow. So for instance, issues with source quality or packet drops at ingest are bound to impact the quality of experience down the stream and degrade the playback experience at the end devices. Further down, during the post-transcoding stage, video and audio artifacts may be introduced due to overcompression or re-encoding. There are also chances of incorrect signaling of encoder boundary points, which are used for chunking of audio-video segments in the packaging stage. During packaging, the content needs to be made available in multiple ABR formats, needs to be DRM protected using multiple DRM schemes, and all the bitrate variants of the content need to be conditioned for ABR such that the bitrate switching at the end devices is seamless. And once the content is published on the origin server, the origin server becomes a source for all the caching and the replica servers in the CDN. So if there is anything missing on the server, like missing segments, or if there are issues with the origin server performance, these are very likely to have adverse effects downstream. And after content handoff to CDNs, there is not much that you can control unless you're using a private CDN, which makes it all the more important to monitor the content delivery performance at the CDN edges. And issues with CDN caches or the response time at the CDN edges, these are some things which are like very hard to resolve. And finally, the end user experience is what ultimately matters. So with so many different device types, screen sizes, and most importantly, the last mile internet connectivity ranging from, let's say, the mobile hotspots to broadband to fiber connections, there are high chances things can break at the last mile, leading to unhappy customers. So with this multi-dimensional problem around CDN or ISP or device, the best approach can be to zero down the specific parameters, like which CDN, which ISP, etc., and resolve the issue as quickly as possible. So what all of this basically hints at is the need to be able to ideally monitor and track down the issues at all these points, isolate the faults, and resolve them as soon as you can. For stored program content that has already been through the various QC stages and is available on demand, probing at all these points may not even be necessary. But for live events where content production, processing, and repurposing is happening on the go, and where interruptions during playback can lead to extremely unhappy customers, multi-point monitoring plays a very crucial role. So let's say we have this live soccer match being broadcasted, and there are millions of users glued to their devices, waiting to look at the match and do not want to miss any of the magical moments in the match. Now, some of them are seeing this bad video quality, this blocky video that you see in the picture, while others are still waiting for the video to load. And some of them are seeing frame drops. Truly not a very great situation to be in for the OTT service providers. And unless you know what is the issue, where is it happening, it is almost impossible to fix it. And being proactively aware of issues and fixing them even before your customers find them for you is what is desirable. So now in this case, for example, if we talk about the bad video quality, that might be a result of switching to a lower bit rate, which may be just to overcompress that it becomes useless for watching. Something that we could figure out post-transcoding. While if you look at the buffering issue, it might be a cache performance issue at some of the edge locations, which can be checked for by QoS monitoring at the prime locations. Whereas the frame drops may be attributed to packet drops at ingest, which means the source validation is important too. So needless to say, with so many OTT services out there trying to pursue viewers, what differentiates a premium service from the rest is its superior quality of experience, which undoubtedly requires well-planned quality control and monitoring practices across the workflow. Now, the best or ideal case deployment of probes at all points in the workflow may not be a viable solution because of the cost involved or maybe some of the infra limitations. Therefore, it is very important to understand the most critical issues that we're facing today and that need to be addressed, and we need to plan the monitoring points accordingly. So with these specific test and measurement requirements at all these points, Interra Systems offers different active and passive probes for monitoring. Orion, which is a real-time content monitor probe, can be used for active monitoring of linear transport streams, ASI streams, STI, or STI over IP. Whereas the ORION-OTT probe can be used for active monitoring of OTT content at origin as well as the edges. And both these probes can be used for monitoring the quality of service as well as the quality of experience. ORION-OTT Origin Performance Monitor, it is a passive monitoring probe that you can use to measure real-time performance of the origin server based on the real user traffic incoming on that server. Whereas ORION-OTT End Device Performance Monitor, this is also a passive monitoring probe that integrates with end device analytic solutions like NPOS Yobora to monitor the QoE metrics for end device playback and helps correlate these with the monitoring information from upstream probes. Now with multi-point monitoring for sure, it'll generate high volume of alerting information from all the different probing points that we have in the workflow. So plain data aggregation of all of this information may not be very useful. And without a single dashboard for the entire workflow, or without considering alert propagation from one stage to another, with no real-time tracking of the error sources or the inability to do the root cause analysis, plain vanilla multi-point monitoring is not very effective. Whereas multi-point monitoring with some real-time data mining that can identify error propagation and draw correlation between errors detected in the same service across various stages, enable root cause analysis with fault isolation, and provide clear KPIs for measuring the channel performance is what the modern broadcast and network operation teams need today. So for effective multi-point monitoring, what you need is an advanced and centralized monitoring platform that provides intelligent and holistic insights for your entire streaming workflow. Orion Central Manager, or we can call it OCM, along with Orion and ORION-OTT probes placed at strategic locations, provides you that advanced centralized monitoring platform that can perform end-to-end monitoring of a channel, aggregate and correlate alerts across the workflow for meaningful insights, provide real-time confidence monitoring with near real-time views for your streams, enable performance monitoring across locations, provide management of all probes under one roof, generate workflow level alerts over email, SNMP, or REST, and of course, provide executive and MIS reporting. Like all other solutions from Interra, this one is also a software-based solution and is supported on Linux and can be deployed on-prem or on cloud. And it is designed to scale and support large number of probes. So with that overview, let's get some insights into some of the core functionalities of OCM. To start with, let's look at how OCM does all the alert aggregation and correlation across the workflow. Alert aggregation and correlation in OCM is based on the premise that an alert at stage A at time t may be seen at a later stage at time t plus delta t in the same or different form. Now we'll look at some examples to understand what is meant by same or different form. Basis this premise, OCM aggregates alerts from across the stages, taking into account the order of the stages and the workflow latency to generate workflow level alerts that help to identify the error source. So on the screen, you can see alerts generated for a channel along with dimensions such as stage, locations where it happened, the start and the end time, and the active status of that particular alert. Let's look at some examples for more clarity. Let's revisit the Blocky video live soccer match example that we saw a few slides back. And let's backtrace the problem. Here we are seeing blockiness error at origin as notified by the ORION-OTT probe. We can see the same blockiness error reported post-transcoding by the Orion probe. And further upstream, we do not see any such error at the source. So our root cause analysis says that the video quality degraded due to over-compression during transcoding by using some very low bitrate encoding profiles. So this is a case where we can see the same problem of blockiness reported at two different points in the workflow. I would say it's a relatively simpler problem since it's easier to relate blockiness with low bit rates and over-compression. Now, in that same match, we also saw frame dropouts during playback. And here we see black frames and audio silence error at origin and also at post-transcode. However, we do not see the same issue at the source. But what we do see at the source is signal drops. Highly unlikely that you would think about packet drops causing this issue unless you look at the complete end-to-end picture where signal drops at the source transform into black frames or freeze and audio silence downstream. And looking at these alerts in isolation may not provide very useful information. However, when seen together, it clearly does the root cause analysis for us. Yet another example where while testing playback on end devices, you're seeing video jumps either forward or backward, and you're switching from one bitrate to another. Now with manual monitoring, there are remote chances of figuring out what is causing this behavior at the device. And even if you would, I guess it will require a lot of back and forth between the different teams to identify the root cause. But if you're using a tool like OCM that understands the cause and effect between the video jump observed on switching and the alerts reported upstream, and shows you a problem of mismatch in first frames at both origin and edge, and the encoder boundary point errors at post-transcode, it becomes quite easy to resolve these issues, these kind of issues, which otherwise require a very deep understanding of the underlying techniques that are being used for encoding and packaging. So in this case, the encoder team basically needs to fix the EBP alignment error so that the switching issue on the end devices is resolved. With that, let's look at the alert correlation report in OCM's user interface. Here you can see the alert timelines for a channel across different stages, and you can also view these timelines grouped across different locations. Further, you click on any of the alert blocks and shows you alerts seen in that channel at the specific time instance. So this one shows you the EBP alignment errors at the post-transcode and the first frame mismatch errors at origin and edge, isolating the fault very clearly. Another interesting example where intermittent play failures are observed at the end devices. Now, typically to resolve such issues, you would ask the user to check for slow speeds or talk to ISP for connectivity related issues. And in some cases, this might turn out to be the actual issue. But at times, this can just keep going on and on until one day when customers decide to give up on the subscription. So in such situations, the OTT service providers are much better off to first validate if everything is fine in their network and at the concerned edge locations. For instance, in this case, we can see some HTTP 5XX errors reported at the edge, but everything is green at the origin. All of this pointing to CDN performance issues causing play failures at the end devices and not the last mile network connectivity. So something that you can proactively figure out using active monitoring tools and fix these issues before your customers even reach out with complaints. We can look at how this shows up in the OCM UI. You can view the end device report for a channel in OCM. It shows all the key QoE metrics for the channel as seen on the end devices. For example, the happiness score for a channel, which basically depends on the quality of experience of the viewers, the join time, buffering ratio, play failures, and more. On the left, it shows the total plays for a channel over a period of time, along with a time series of any of the QoE metrics. In this case, we can see in-stream failures reported over a period of time. And these colored bars at the bottom indicate related alerts reported for this channel in the upstream probes. Clicking on any of these bars shows you a detailed view of all the errors reported for that time instance. And we can see over here, we can see HTTP 5XX errors reported at the edge and stream failures reported at the end devices thereafter. So that's alert correlation and fault isolation made simpler with OCM. With these intuitive reports and intelligent alert correlation, you know what is happening in your network, where is it happening, and why is it happening. Next, let's take a look at another key requirement for monitoring of end-to-end ad insertion in an OTT workflow. From SCRT 104 in SDI to SCRT 35 in transport streams to a variety of ad markers in the ABR manifest, ad signaling plays an important role in any ad insertion model, whether it is server-side or client-side. With Orion and ORION-OTT probes, we support monitoring of ad queue messages in transport streams and ABR streams, respectively. These probes are capable of performing compliance checking of queue messages, check for the ad policies like how long should an ad be, what should be the ad frequency, and more. And these are even logged for historical reports and debugging. So this screen shows an out point in a TS stream with neighboring thumbnails around the splice point. You can see frames before and after the splice point to verify the correctness of the splice positions. A similar view for a queue point signaled in a HLS manifest file, where you can look at the neighboring segments just before and after the ad markers, and also the manifest data which signals those ad markers. Now, with ads emerging as the primary revenue generation opportunities for OTT services, losing out that ad signaling in the workflow is like a potential revenue loss. Thus, ensuring that these ad queue messages are translated correctly and timely from linear transport to ABR content is important. And while looking at the ad markers from one stage to another, you also need to consider the inherent latency between the different stages in the workflow. Also, ensuring that the ads are played out as per the schedule is equally important. So on the screen, you can see an ad schedule report for a channel showing the ad playlist on the left with the expected avail start and end times, and the corresponding times seen at pre-transcode, post-transcode, and origin. And anything missing is marked as red. So if you look at the second row, we see that the ad marker is completely missing from all the points in the workflow. Whereas in the fifth row, we see that the ad marker propagated correctly up to the post-transcode stage, but there were no markers in the ABR manifest. So this is one of the upcoming features planned for the future releases of OCM and should be out there in the product very soon. So apart from all the alert trending and the historical reporting that we've discussed, OCM also enables real-time confidence monitoring with almost near real-time live updates of channels across various stages and locations. And with these live views, you get to know what's happening with your streams at that very moment. There is a live channel mosaic view that shows live thumbnails for the channels. There's an option for penalty box monitoring to look at the channels that are currently in alarm state. These thumbnails provide a compact view for the channel status at different points in the workflow. These dots at the top of the thumbnail, these represent a stage in the workflow and the status of that stage. And at the bottom, you can see alert timeline and the current channel availability numbers. An alternate lineup view, which shows the channel lineup status with more detailed information of all locations where it is being monitored, status at the different stages, and more. Click on the channel and you can look at the channel performance report showing the alert timeline, alert trending across stages, locations, and the different variants of that channel. Next up is the live workflow status that aggregates monitoring information per stage and helps you identify the erroneous hotspots in the workflow. So on the screen, you can see the alert status at a stage, most erroneous channels in that stage, and also the most commonly occurring issues observed in a particular stage. So very useful as a dashboard-like view for the NOC where you can easily identify the bottlenecks in the workflow. Performance monitoring across locations is particularly useful when you're delivering content in multiple geos via distributed edge locations. So knowing proactively about whether your content is being properly streamed at all the locations, especially the ones with more premium viewership, helps you deliver your content with confidence. The map gives you a bird's eye view of your network from where you can drill down to the problematic areas up to the grassroots levels. And last, but definitely not the least, with so many probes being used in the network, you definitely need management and control of these probes from a single point. So from configuring common checks and settings like using a common QoE profile for all the probes that are monitoring quality of experience, likewise using a QoS profile for all the probes monitoring quality of service, to even monitoring the operational stats, the health of all the probes, OCM provides you with that ability to manage all those probes at one single place. So that brings us to the end of this presentation, where we would like to quickly summarize by saying that irrespective of wherever you're delivering content in this world, an advanced and centralized monitoring platform like OCM with carefully thought and well-planned probing at all the strategic locations enables you to deliver your streams with confidence and the best quality of experience for your viewers. So hope this presentation gives you some insights into holistic OTT monitoring with OCM. With this, I would like to thank you all for attending this presentation, and hopefully each one of us has some takeaways from this, and we hope to engage with you in more specific discussions going forward. Thank you once again, and have a good day.
Thank you, Raman.
Okay, thanks a lot.